Hello everyone. This is the lecture about System of Linear Equations, Part 2, Terminologies. This part still belongs to section 1.1 of our text. And after this lecture, you should understand what we mean by M by N linear system. In particular, what do we mean by M, what do we mean by N? And we also need to find out coefficient matrix and augmented matrix given a linear system. A general form of linear system is given here, and this is called M by N linear system, and M obviously stands for the number of equations here, 1, 2, all the way to M. And N stands for the number of unknowns, x sub 1 all the way to x sub n. So given a linear system, M by N linear system, your task is to find all unknowns, the value of unknowns. So you need to find n many numbers. All the other numbers like a sub 1, 1 all the way to b1, a sub m1 all the way to bm are called coefficients, which means given numbers. Now, from the coefficients or given numbers, you can pull out all the numbers on the left-hand side. So we can form up a matrix, M by N matrix. So if we recall the equation here, the coefficient of x1 in the first equation is a sub 1, 1. So you can put it in the first spot of this matrix, first row and first column. And for example, a sub to n is the coefficient of x sub n in the second equation. Now, we can use b to represent all the given numbers or all the coefficients on the right-hand side. This is called non-homogeneous term. So B stands for B1, Bm, which is M by N matrix, or you can say M-dimensional column vector. And it has a name non-homogeneous vector. Now we can put the coefficient matrix and non-homogeneous vector together. We can form up M by N plus 1 matrix. This is called augmented matrix. Now we have definition of coefficient matrix and augmented matrix for a given M by N linear system. We're going to look at one example. So here we are given a linear system which has three unknowns, x sub 1, sub 2, sub 3, and three equations, 1, 2, 3. So this is called 3 by 3 linear system. So we have 3 by 3 linear system, and we want to write out coefficient matrix and its augmented matrix. And the last task for this problem is to check the candidate solution. 3, 2, 3. There's redundant n. We can take this out. All right. The coefficient matrix is the matrix formed by all the given numbers on the left-hand side in front of variables. So we can write this down from first equation. In front of x sub 1, there's nothing, which means 1 multiplied by x sub 1. So we can manually put 1 as a coefficient. And the second number is 2 in front of x sub 2 and negative 1. From second row, we can pull out negative 1, and 2. And from third row, in front of x sub 1, the coefficient is 1, but there's no x sub 2, which means we can manually put 0 times x2, which does not change the original equation. So we can treat its coefficient as 0. And x sub 3, its coefficient is 1. So this is coefficient matrix. Now, we're going to look at augmented matrix. First of all, augmented matrix is coefficient matrix with non-homogeneous vector. So we can just take coefficient matrix and copy and paste. And to distinguish the right-hand side and left-hand side from the system, we should put a vertical line. And then we are going to move all the numbers given on the right-hand side to the right-hand side of the vertical line. And this gives augmented matrix. Now the last question is about check the candidate given by 3, 2, 3. What it means is you need to plug in the number to 3 equations and verify their inequalities. So what you need to do is from the first equation you are going to replace x1 by 3, x2 by 2, and x3 by 3, and you should verify this is correct or not. Similarly, you can verify the second equation. So this is negative 3, negative 2, plus 2 multiplied by 3, which is yes or no. And from the third equation, 3 plus 3, is it equal to 6? If you can verify all the question marks as true, then the answer is yes. The candidate solution is indeed a solution of linear system. Let's try another example. This time the linear system is 2 by 3, 2 equations, 3 unknowns, and we are asked to find out the same questions: coefficient matrix, augmented matrix, and check candidate solutions 3 through 3. And the last question is, can you say something more? All right. If we go back to the previous example, we will see that the last 2 equations are exactly the same as this example. So this example is essentially the same as the previous one, except we deleted the first equation. So the coefficient matrix is obviously we can take advantage of the first one, the first example, so we can just copy and paste. And that gives me coefficient matrix. And we can also do the same thing for augmented matrix from previous one. So copy paste the last two rows. So I'm going to skip that. Number 3, we can check the solution. We have 3 equations to test, and in the previous example, it passed all the tests, all 3 tests. Now, here, because we have 2 equations, we only need 2 tests. And if this candidate solution can pass all 3 tests, of course, it can test any 2 of them. So the answer is yes, too. Number 4, can you say something more? So compared to the previous example, we have one less equation, the first row. So what difference it brings me to this new example by having one less example? So to be more specific, we can try different candidate solution. So we can think of 6, -7, and 0. So as an alternative solution, alternative candidate solution, and you can check that if you put 6, -7, 0 to both equations, we'll see it satisfies. It satisfies both equations. So for example, for the first one, you can check -6, -7 plus 2 by 0. Is it equal to 1? So this means -6 plus 7, which is 1. So exactly. And the second equation is 6 plus 0 plus -7, which is it equal to, no, sorry. So the last one supposed to be 0. x3 is 0. Is it 0? 6? Yes. Which means this new solution is indeed a solution of linear system. Both tests are passed. Now what we can say more, here we expect following answer. Probably we have more solutions than the previous example if you compare this. So 3 equations, 3 unknowns. Intuitively we can, from previous example, we can expect exactly one solution given here, 3 to 3. So this is unique solution. And here we find 2 solutions, which means uniqueness does not hold. In other words, there may be 2 solutions, or maybe 3 solutions. So the question is, how many solutions can we find from this equation? And can we solve this kind of linear system even with different coefficient matrix? Can we do it systematically? So this goes to the next lecture.